I'm very happy to be here again because you may see me many times in RISC-V workshop, and I'm Fedora from Red Hat. I'm the software engineer working in hardware enablement team. That means I'm working in a low level of software. I pretty care about chip and RISC-V because it's a rising star in this area. So in this session, I will talk about two things. One is give you guys a big some update for Fedora on RISC-V. That included a little bit history. I give a lot of detail in the previous talk. So this time I will just give you a very brief summary for this history, and also give you the status of Fedora on RISC-V, and let you know what is the facility we are using for building Fedora imaging, and let you know what kind of target we are support. And in the second part, I will talk about industry standard RISC-V server PC proposal and current status. And so let's go. In my previous presentation, I already talked about why we are using native compiler, why we are using Bootstrap to make Fedora running on it, and the relationship between Fedora, RHEL, and CentOS. But if you're interested about that, please let us know. I'm very happy to can just explain this thing to you. In this picture, you can see what we have done in Fedora on RISC-V Bootstrap. Nearly 2 years ago, Richard Jones, who is a pioneer in this area, he made RPM build running on QEMU for RISC-V. And I saw it's a historical milestone in RISC-V, I think, because once we can run this tool, that means we can build a package. We can make a Fedora imaging from that. So after that, the other two developers joined this developing procedure, and after 2 months, they finished that, and there's a first bootstrap for Fedora on RISC-V, but it's just a trial because Fedora has upstream first policy. We got everything from upstream. We don't use any patch set from any individual guys, and we just got everything from upstream. So we need all the key patch set to be upstream, and like Linux kernel, toolchain, and glibc. So we are waiting for all these things until 2018. So the last pieces, glibc patch set, be merged in December 2017. So, but in this period, they didn't really just wait. They run the second bootstrap for Fedora 27 as a preparation. So once they got the information, okay, the final piece has been merged. So they immediately start a third bootstrap for Fedora on RISC-V. So in 2018 March, they finally finished that. They consider the final bootstrap for that. And then they keep working on that. They make a Koji build system, set it up. So right now, all the package, all the imaging will be built in this distributed building system, and we don't have to do the cross-comply every time, and we just need to submit a job to this Koji system, and this system will distribute all the tasks to different hosts and build the imaging for us. So, and then another good milestone for them is they made Genoa working on it. I heard some people ask about, they want a Genoa support. So yeah, once the hardware support that, we will manage to make Genoa and the graphics things running on it. So you can see, long time ago we are using QEMU, but right now we can have some hardware to use, and so they can accelerate our build procedure. Right now in our Koji system, all the package has been built in here, and we have two active projects. One is current version, Fedora 29. Another is a future version, we call it Roughheight, Fedora 30. And once we build all the package and imaging, we will put the resource to Fedora mirrored website. So you can download it in this website, and it's become a Fedora alternative architecture, just like ARM several years ago. So we can start from there and see. In some days, we have server running RISC-V server running Fedora. So in our Koji system, we have server hosts to build a package for us. We have 3 Hi-Fi Unleash, which one of that has SSD in it, so they can build the imaging very quick. And the reason we use that because in the real hardware, the building procedure is much quicker than the QEMU. But we just have 3, so we also set up some QEMU VM in some x80 server. Right now, thanks to Facebook's donate, we have 64 QEMUs virtual server running in it. So you can check these things. You can click this icon and get into the website. You can check all the job and all the hosts. We also have 3 servers as a central infrastructure of Koji system. So right now we are building 4 different types of package imaging. Most frequently built is Fedora developer. Is allow people to build a kernel and package natively on your hardware, or maybe on your QEMU. And we also provide a very small imaging, which allow you to test your hardware and software very quickly. Developer and Genoa imaging will normally be 2 or 3 gigabytes. So we provide some small imaging that you can test your hardware. Make sure it will not too big, and make sure you can test it quickly. And we also provide a Genoa imaging. It's imaging which include all the package in developer imaging, and then include Genoa desktop GUI support. If you got this imaging and you're lucky enough got a Hi-Fi Unleash board and with extension board and PCIe graphic card, you can run this Genoa desktop on it. Okay, so right now the PCIe graphic card we are using is AMD's open source graphic card. So not all is package, not all is imaging be built frequently. We only build developer a minimal imaging scheduled automatically, because if we need to build a graphic one, we need to build a genome imaging. It needs 3 days. We don't have too much VM and real hardware to build it, so it costs too much. So we just build the developer and minimum imaging. Right now we are support QNU officially. You can just download the imaging and try this on QEMU. We also support, if you want to use the libr and the QEMU, you also be support in our official release. And recently, just I think yesterday, I got the information from a main developer in this project. He told me we can run QNU with graphic parameter, so you can try genome imaging on QEMU, and it can show you the graphic window. It's a quite exciting moment for us. And also we support some hardware, but for Hi-Fi Unleash, because there's we only take the patch set from patch from upstream, from the source code from upstream. So in the upstream kernel, it lacks some support. So you have to build the kernel by yourself. It requires a custom kernel build. It's not supported in our release, the latest release, the disk imaging. You have to build the kernel by yourself. And that's a picture in my home, and thank you thank you Sci-Fi to provide this hardware to me. And that's the screenshot. You can see the screenshot. I just take the screenshot in this board, and I not take a picture. It's a screenshot in the graphic in the Genode desktop. So I'm very happy to announce that right now we also can run Fedora on ND-style Wi-Fi platform. I hear that just now, Andy's engineer mentioned this, so I'm very happy to see that. And we can run Fedora imaging on ND-style's QEMU platform and also on FPGA platform. And Andy's take a great effort on this, and I very appreciate that because they push everything upstream. And we just need a very little patch for mainline kernel. So it although it haven't been included in the latest disk imaging temporarily, but I so believe we just need very little patch. Once this patch be upstream, we can officially support in our Fedora imaging. So if you are building a 64-bit imaging, 64-bit hardware, 64-bit chip, please let us know. Why people choose RISC-V? Because that means rich hardware ecosystem and rich software ecosystem. So as a Fedora, we always open. We want to put Fedora on all kinds of different hardware, but if you are building this hardware, we want to know some information from you, and we want the development platform from you, and we can cooperate in very early stage. So why we are here again? I show this picture several times, right? Because we want to, I hope, RISC-V long life and prosper. So for the ecosystem, if we want to use the RISC-V in PC and server area, we have to make RISC-V machine boring, right? Because in the data center, administrator need to maintain thousands of nodes. If some of the node behavior different, need to install the software differently, it will be the nightmare for this administrator. So we have to make the server out of the box. Spawning is exciting things for us. So we can learn from the other architecture like x86 and ARM. For x86, we only have two vendors to produce a chip. So it's not a problem for them. They can easy to have agreement. But for ARM, they have thousands of different chip vendors. Even for the server chip, we also have several chip vendors. So for this unified server platform, Red Hat and Linaro take a very great effort on this to make the spec like SBSA and SBBR. Eventually, ARM server can be out of box. So we also need to do this on RISC-V. And what is the status for this? I'm very happy to see some of the great company already working on it, like HPE. I got all this information from one of the HPE engineer, Ambner. He is here, so if you have any question, you can ask him. I will give you some summarize of the great progress they have made. First of all, is for UEFI. You may know all the server in the almost all the server in the data center. If that is a standard server, they should use the UEFI. Right now, HPE engineer has made UEFI running on Sci-Fi Freedom development toolkit. Although they cannot make kernel be booted because one of the things we lack support from EFI kernel. But it's a great milestone for this development. They also contribute on SM BIOS. They already propose SM BIOS type 44 processor additional info to the working group, and it's in the ballot process, and we may see that in version 3.3. And for the RISC-V specific SM BIOS type 44 is published on RISC-V GitHub. But you cannot see that right now because it's private. Once the working group approves this proposal, you will see that we will tend it to public. And also for the CIN, HPE engineer also made these things be approved, and it will be published in this schema will be published in version 2.52. And then let's something about like the server side. But let's see something about impact system side. Maybe you just heard that U-boot has the patch set for enabling RISC-V in U-boot has been merged. And you can see the demo or some information in Atish's presentation on another conference. They can make open SBI, U-boot, and then boot Linux kernel. So it's another great milestone for that. For grub, because in Linux system, most of people using grub as a bootloader. So for grub patch set from Alexander it has been merged, and but we're still missing the EFI support in kernel. It's so-called EFI stub kernel. It has been finished in on-site, but we still need this support for RISC-V. So what is the next step? In this area, for the ACPI side, we need a NADT subtable be updated. We also need SDEI because we also need SDEI. SDEI, DI come from ARM, but we made the same. We have the same problem in RISC-V, so we may need to update this table. If you want to use RISC-V in the server, we also need the refresh schema change for RISC-V. And some of the PCIe card require the PCIe extension room to initialize the PCIe device during the pre-OS system post. So like some VGA card, storage, RAID card. So therefore, the RISC-V port of a UEFI driver for PCIe card is also required. This problem also in ARM server. So right now, we also need the card vendor to support this, put this RISC-V support into their PCIe card. There are some proposals for OpenSBI. We register like some function like register superior mode handler to handle machine mode interrupter for hardware event. We also need to transfer privilege mode in platform level VN storage, read-write function, and some other more functions we also need it. So at last, we all have some proposal. This proposal comes from HPE. For UEFI, we enable pre-OS UEFI environment to execute EFI driver in different processor privilege levels and protect the critical hardware. We also need if you need to build UEFI, maybe you need to combine the binary with UEFI and the OpenSBI. So how to integrate these two different software? So there's some two proposals from HPE, and they successfully made some tests on that. So if you have any question about this firmware update, about this firmware proposal, you can contact these two great engineers from HPE. So great thanks for all the people who support this project, who donate their hardware and software to this project. And thank you very much.